It would extend to Jupiter's ring if you placed it where the Sun is. It's enormous, genuinely unstable, and about to blow up. With the potential to produce energy equivalent to 1 billion suns, these explosions rank among the universe's largest radio energy explosions. Are you ready for what's about to occur? One of the closest stars to Earth, the massive red supergiant Betelgeuse, has recently seen a notable dimming that has drawn attention and generated conflicting emotions around the globe. The public and cosmologists have speculated about the possible implications of this darkening. This unexpected behavior, according to some scientists, may be a sign of a cosmic explosion, a cataclysmic occurrence that happens when a star runs out of atomic fuel and collapses under its own weight, resulting in a huge burst. The public is likewise concerned about such an occurrence since it raises doubts about its potential effects on our planet, in addition to mainstream experts. Because of its distinctive form and brilliant stars, Betelgeuse is a unique star cluster that is simple to identify in the night sky. It is the largest and brightest star in this constellation and is also known as Alpha Orionis. According to recent data from NASA's Hubble Space Telescope and observations from other observatories, there was a notable mass influx of Betelgeuse in 2019. Astronomers from all across the world are interested in this behavior since it is uncommon for a star of its kind. Although coronal mass ejections occur frequently in our own sun, the remarkable event observed in Betelgeuse gives an interesting dimension to our knowledge of the mechanics of big stars and their life cycles. Astronomers are still debating the distance to Betelgeuse. There are differing estimates of its distance from Earth. Some put it at a distance of up to 724 light-years. Because of their massive size and unique characteristics, red supergiant stars like Betelgeuse are difficult to measure accurately. With a luminosity several times higher than the Sun's, Betelgeuse is one of the brightest stars that can be seen in the night sky. Betelgeuse accelerates the star's impending demise by burning through its atomic fuel at a faster rate. But this incredible brilliance comes at a terrible cost. The star will eventually run out of fuel, which will cause it to abruptly collapse under the force of its own gravity. This could cause a cosmic explosion that could give rise to a black hole or neutron star. Does Betelgeuse constitute a hazard to Earth? If our current astrophysical assumptions turn out to be accurate, the effects could be catastrophic if a cosmic explosion happened a few hundred light-years beyond our planet. A supernova's explosion can release an incredible amount of light, potentially as much as that of an entire galaxy. As a result, Betelgeuse's cosmic explosion may have profound and far-reaching impacts even if it is relatively far away, similar to the star Alpha Centauri. Amazingly, since the last known cosmic explosion in our galaxy in 1604, no local occurrence of such an explosion has been reported by humans. Still, in 1987, there was a significant cosmic explosion in the Large Magellanic Cloud, 169,000 light-years away. Even though the event had a significant impact, Earth was not directly in danger. Rather, it served as a reminder of the scope and potential consequences of such cosmic phenomena. The idea of a danger zone encircling a normal cosmic explosion is intriguing and, should a supernova occur close, might have catastrophic consequences for life as we know it. However, it's crucial to realize that, within the wider context of the cosmos, close supernovae are rather insignificant events in contrast to gamma-ray bursts, which are significantly more potent and represent a distinct kind of threat. Devastating gamma-ray bursts have the power to wipe out biospheres and cover planets in deadly radiation. For instance, a particular kind of cosmic explosion may result in the depletion of a planet's ozone layer, leaving it exposed to space radiation for a considerable amount of time following the explosion. This possibility was brought to light in a recent study that described novel dangers connected to huge stars that die in such a dramatic way. Massive stars have the ability to reach some of the universe's brightest radiations when they explode as supernovae. A single supernova's brightness can really eclipse the sum of billions of stars' luminosities. This begs the issue of what would happen if Betelgeuse experienced such a massive explosion. Betelgeuse would overtake the Sun as the second brightest object in the sky in the event of a supernova. Amazingly, Betelgeuse, which shines brighter than a full moon, would become visible during the daytime even if it is far away from us. The explosion's sheer power would provide a show so magnificent that shadows would be visible even in total darkness. A spectacle like that would demonstrate the unadulterated force of cosmic occurrences and be both horrifying and inspirational. Even while a supernova's visible light is amazing, it only makes up a small portion of the energy released during the event. While exposure to high visible light levels may temporarily impair vision, the high-energy radiation released in tandem with the visible light is of more concern. This radiation frequently takes the form of gamma and X-rays, which can have devastating effects. The capacity of this high-energy radiation to accelerate the ozone layer's thinning, which shields our planet from dangerous solar radiation, is one of the biggest threats it poses. Life on Earth's surface would be exposed to intense UV radiation from the sun in the absence of a strong ozone layer, which could result in mass extinction events. While there are acute concerns following a supernova, over time, the solar system is being penetrated by cosmic rays and subatomic particles moving at near-light speeds. The hazards created by the original explosion can be increased by these enormous rays, which have the ability to destroy ozone layers and cover the Earth in dangerous radiation. Moreover, a significant amount of the energy produced by the supernova is carried by these cosmic rays, and their long-term impacts may last for hundreds of years. Evidence of the possible impact of such events on Earth in the past has been found in seafloor sediments and lunar regolith, where high concentrations of iron-60, a radioactive isotope created in supernovae, have been detected. This discovery raises the possibility that Earth was affected by supernova ejecta relatively recently in geological history, possibly in the last few million years. Based on our understanding of the dangers posed by cosmic rays and gamma rays, astronomers have already concluded that there aren't any close supernova candidates that could endanger life as we know it. Ongoing investigations, however, have uncovered fresh dangers connected to particular kinds of gamma-ray bursts. Planets like our own are more vulnerable to the deadly radiation that these gamma-ray bursts can create across long distances. The mechanism behind this is that a massive disk of material surrounds a star that is approaching the end of its life. This disk is struck by a shock wave produced by the explosion, which causes it to heat up extremely quickly. This thus generates a substantial quantity of high-energy X-ray radiation, which is capable of traversing vast expanses of space. A planet's ozone layer might be cut in half by the most intense X-ray supernovae, which could lead to conditions that could eventually cause an extinction catastrophe within 150 light-years. Luckily, no potential supernovae have been found in Earth's local neighborhood. On the other hand, new knowledge about the cosmic habitable zone, the area of galaxies where conditions are favorable for life, has resulted from this research. These results imply that there might be further restrictions on this livable zone. In particular, there might not be enough star formation activity in a galaxy's outer regions to generate the ingredients required for the formation of rocky planets. In the meanwhile, there are concerns in the inner areas as well because there is where stars develop and perish more quickly. These areas have frequent supernova explosions, which can irradiate the surrounding space and raise the dangers for any potential life that may be there. Our concept of where life might truly flourish is being altered by new research that suggests the inner edge of the cosmic habitable zone may be farther from the galactic center than previously believed. What then will be the earthly appearance of the Scarab-Juice supernova? Earth's biospheres probably won't be impacted, but it will still be hard to miss the sight. Experts predict that Scarab-Juice will glow brilliantly for almost 90 days after it explodes, achieving a luminance that is half that of the moon and considerably lower than that of a full moon. In essence, it will be visible even during the daytime as a bright spot in the sky. Anybody looking up will be mesmerized by its breathtaking brilliance, which even casts shadows at night. People on Earth will surely be fascinated by this spectacular astronomical event, since the explosion can be seen with the unaided eye for several months. Although Scarab-Juice's leftovers will eventually disappear, scientists are still studying it to learn more about the mechanisms that caused a huge star's terrible deaths. Gaining knowledge of these enormous events is essential to understanding how our galaxy has evolved and how elements are created during a supernova explosion. In addition to visible light, the explosion's extreme heat and pressure forge a wide variety of heavy materials, including uranium, silver, and gold. Nucleosynthesis is the process that enriches the interstellar medium with the building components needed for the development of stars and planets in the future. It's interesting to note that supernova remnants, or the remains of a supernova explosion, have the potential to develop into a stellar nursery where new stars are created from the gas and dust released during the explosion. This cyclical process demonstrates how cosmic events are interrelated and how the demise of one star can trigger the emergence of another. The dynamic character of the universe is demonstrated by the discovery of several supernova remnants that continue to generate new stars long after the original explosion. Supernovae function as cosmic distance markers is another intriguing facet of research on them. ASTER, white dwarf star type I supernova explosions, which consistently reach their maximum brightness, are used by astronomers as standard candles to measure universe distances. This technique has made a substantial contribution to our knowledge of cosmic expansion and the identification of dark energy, the enigmatic force responsible for the universe's expansion's acceleration. Furthermore, researching supernovae provides information about how habitable exoplanets might be. Researchers are looking into how planets orbiting neighboring stars might be affected by the radiation released during these cosmic explosions, and how it might affect their atmospheres and the possibility of life. The significance of comprehending the environmental factors governing life throughout the universe is highlighted by this research. There are interesting questions concerning how society might react to such cosmic events when a nearby supernova is observed. Supernovae have influenced stories, folklore, and artistic creations throughout history. Beyond merely being a scientific phenomena, a star's explosion takes on symbolic significance in human culture, signifying transformation, devastation, and rebirth. Bright new stars have long been seen in the night sky as messages or signs from the cosmos, according to many societies. In addition, technological developments have completely changed how we can find and analyze supernovae. Modern sensors on space telescopes enable the capturing of fine-grained pictures and spectra of these events, disclosing their structure and behavior. Additionally essential to the monitoring of fleeting phenomena are ground-based observatories, which enable astronomers to gather data in real time and react swiftly to observations. With the development of new telescopes and technologies like the James Webb Space Telescope, supernova research has a bright future ahead of it. These developments could provide extraordinary insights into the dynamics of stars' cataclysmic deaths and life cycles. These observations have the potential to significantly advance our knowledge of the basic processes that form our universe and the evolution of stars. In conclusion, research on Betelgeuse and the upcoming supernova event opens doors to more extensive conversations regarding universal recycling, cosmic development, and the effects of these occurrences on life and society. Studying such big stars helps us understand the complex and sometimes violent cycles that rule the universe and helps us understand our role in this vast and constantly changing universe. Supernovae, which signal the end of a star's life and the subsequent construction of new celestial structures, are also important events in the greater cosmic chronology. Nebulae, which are enormous clouds of gas and dust that serve as ideal environments for the birth of new stars, are one way that the leftover debris can change over time. These areas may include complicated chemistry, which aids in the formation of organic molecules, which are the building blocks of life. Supernova explosion shock waves can also start star formation in neighboring molecular clouds. This process, called triggered star formation, illustrates how a single sensitive event can initiate the production of new stars and planetary systems and highlights the interconnection of cosmic occurrences. This emphasizes the importance of supernovae as starting points for further astronomical research as well as ends in themselves. In the big scheme of things, supernovae also play a role in the distribution of heavy metals around the universe, enriching the material that will eventually create future stars and planets and affecting the chemical diversity necessary for life. This cosmic recycling emphasizes how crucial it is to comprehend supernovae within the larger framework of astronomy, as well as the beginnings of the materials that comprise our planet and life itself.